Right.
Ready? Get set. Write this down. The word is set. We're not talking about volleyball here. We're talking about mathematics. What is a set? A set is a group of numbers. A group of numbers. And usually we use a specific mathematical symbol to show a set. And that is my favorite of all grouping symbols. It doesn't always have to be, but it looks like this. Which in math is called a, yeah, the braces. For example, let's just do this off to the side. The set of odd integers would be, you would do this. And obviously you can't write down all the odd integers. Are negative numbers odd integers? They should be, shouldn't they? -3, would that be odd? I would think so, wouldn't it? You would write down this. -3, -1 is 0 odd? No, it's neither odd nor even. 1, 3. Now, obviously those numbers go on forever. How do we show that? My second favorite thing in math. Yeah, which is called a ellipse, isn't it? Or something. ... So that's how you show a set of numbers, is you put the little brace around it. If it goes on forever, you put those little dots, and that just means it continues on. Now, in order to talk about this, we've got a whole bunch of mathematical symbols, children. You will not remember them, so let's write them down. Here they are in no particular order. Are you ready?
Yes.
All right, first of all, let's do the one we just did. The little brace is a set. Shows a set. Got that one down? Second one. This little pitchfork thing means is an element of the set. Not elephant, but element. And if you don't know what an element is, these are the elements. You could also say a member of, I guess. An element is just the number or something that's in the set. Then we have this little shape. It gets better, which means is a subset. Anybody care to speculate what subset is? Well, you should be able to figure it out without me telling you. What is a subset? It would be like if I were talking about the set of 7th graders. A subset would be 7th grade boys. Another subset would be 7th grade girls. A subset is a smaller grouping inside of a bigger one that contains that every part of that is a part of that set. We'll talk more about that later. You ready? How about this one? If you have this little thing like this, this is called the intersection. And believe it or not, we've got an upside down one that looks like a U, which is good because it stands for the union. And we'll talk about all of these later. We're just kind of getting a list of stuff we're going to talk about here. And then the last thing the book says is this. You have a 0 with a little slash mark through it. We call that an empty set. And I think some people also call it a null set. Does null have 2 L's or 1? Who's the spelling person? So are you 100% sure? When was the last time you saw a null? You ready for some more notes? Just say yes.
Yes.
All right. If you go back to probably the first couple days of school, I think we wrote down under numbers these sets, different sets of numbers. If you remember right, and somewhere in your notes you have this. For example, we had the natural numbers. You remember what natural numbers were? Oh boy. classification on numbers, I think. I believe we also called natural counting numbers. Remember what natural numbers were? When your parents taught you to count, what numbers did they give you? 1, 2, 3, 4, 5, 6. They didn't start with 0. Okay? Natural numbers, we use a little symbol that looks like the letter N. By the way, this is also an art lesson for you. Uh-oh. No! No! This can't happen.
It's not. It's
This cannot
It's
happen.
not happening.
Because I have lost everything if I forget this.
What is it? Close your eyes and it'll go away.
No, we're done.
No.
Now, maybe,
Chalkboard?
if we're lucky, this will say that there is a
Backup?
attempt to recover lost data. And
What? Huh? What?
cross cancel. Hold on a second. We'd be way down here at the bottom. Would we be way down here at the bottom?
Well, that's 11 of
Yeah, maybe I should give it some.
Oh, you did.
Look at it. It's like going back in time. Is there more? Because if this is it, we're done.
No.
It could wait. It could be in the middle of some of this stuff. It's not always chronological. 65 slides. Anybody see one? Maybe I can get this bigger. Hold on.
It has like the work stuff.
Anybody see it?
No. Maybe it's all the down? We just trying to figure this.
Is that it?
No. No.
Maybe we started at the top.
Wait, can't you?
Oh! Maybe we could search it. I think we
Wait, go back up.
It was not.
Oh, I
How
thought
can you even see it there? I can't see it. I'm seeing it right
No,
now.
I can't. All of us.
Wait, there was something there.
No.
Remember this?
Oh, yeah.
Oh, yeah.
Oh, yeah.
Oh, that's
Okay.
8th grade. Is that 8th grade or is that you?
That was us.
It was
a
us.
while
It
ago.
was
Don't you really clean this out more?
This was.
I'm not really about cleaning things. I'll wait till you see it. But you'll be after this. Wait, that was. Oh!
That was.
Oh!
Oh.
Oh! That is depressing.
No.
Alright. That's good, because this is kind of a different thing anyways. So we did, this was, the letter N, if you put a little double thing like this and make it look like that, that is the way, a quick way to say natural numbers rather than writing it all out. And then we have the letter Z, which is obvious, stands for somebody, or no, integers. I don't know why. By the way, what are integers as a quick review? Integers are positive and negative
Numbers.
whole numbers. No fractions, no decimals. No fractions, no decimals. And then we have the letter Q, which again appropriately refers to, anybody? Real numbers. It's logical, isn't it? And then we have the letter, oh wait, maybe I did that wrong. I'm sorry, change that.
Oh, big off. Everybody got
Starts with the letter, it's rational numbers. And then, sorry, the letter R, ladies and gentlemen, stands for the real numbers. We do have that somewhere down there, don't we? You do have the notes under classification, the one that had the box with the stuff inside the box. That's it. Grace, yank that out and show everybody. Show your classmates that. No.
Great.
How are you going to put that back in?
I just ripped out, so.
So this little box here, was all that stuff you did. This was way back the first couple days of school.
Yeah.
And talking about subsets, every number that's inside a smaller rectangle inside of a bigger rectangle is a subset. So you would write that like this. The natural numbers, remember the little symbol for a subset was this little thing, right? Is that right? Because I erased it off. Is a subset of the real numbers. So rather than you going through all the work of writing all that down in math, you would just say natural numbers are a subset of the real numbers. because the natural numbers are a subset of the real numbers. Rational numbers are a subset of the real numbers. Integers are a subset of the rational numbers. You would have all that stuff there. Isn't that exciting? Let me see what they actually ask you. Now we have to talk about those other ones. So here, let me give you an example of something that might come up. Let's say you have this. The book tells you that you have set A. Set A is, they give you a list of numbers here, which is a set of numbers. Set A is, oh boy, 1, 2, 3, and 4. 1, 2, 3, and 4. Set B is 2, 4, 6, and 8. Okay. Now those little symbols I gave you, for example, one of them was union. If I asked you for the union of set A and B, when it is union, union simply means you put them together. By the way, it must be a little humid out because my bubbles are coming up a little bit there. So the union of sets A and B would equal, so here's my set, you just put them together. 1, 2, 3, 4, 6, and 8. 1, you don't have to repeat it if it's the same number. I don't put 1, 2, 2, 4, 4. 1, 2, 3, 4, 6, and 8. That is the union. You put them together. Guess what? If it where it said this with the upside down U, the intersection. Anybody want to speculate what intersection is? Well, you can kind of guess. Intersection is
Same number?
yeah, ones that they both have, the overlap. Both sets have. So what do they have in common? If you look at both of these sets, they both have a 2 and a 4. This is the union, this is the intersection of those sets. How about that for very exciting? It's really hard to do this without actually looking at some examples here. Oh yeah, I gotta find some. Open up, let's just look at a couple example problems here because it's really hard for me to do without looking at some stuff there. Look at page 602, 603, please. 600 to 603. Is everybody there? Take one deep breath. Look at letter A. The directions say indicate if the number is an element of the set of integers. That means this. For letter A, you would write this down. -1, and you remember the little symbol for an element of was the little pitchfork on its side? And is it an element of the integers? Wait, what was our symbol for integers? The Z, right? Was it Z?
Yes.
So rather than writing integers, I can write this little Z thing here. Now the question is, if it's true, you leave it just like it is. If it is not true, if -1 is not in the set of integers, you put a little slash mark through that thing. Then it would say -1 is not an element of the set of integers. Is -1 an integer, yes or no, Zach? Zach? Is -1 an integer?
Yes.
Yes, it is. Thank you. Yeah. If you look at integers are positive and negative whole numbers. Letter B says, is 2 an element of the set of integers? Yes or no? Anybody? Integers are positive and negative whole numbers. Is that a positive or negative whole number? Yes. Decimals or fractions, it would not be. Letter C says, is the square root of what? 3. Is the square root of 3 an element of the set of integers? Yes or no? If you put square root of 3 in your calculator, you are going to get some sort of decimal. So you put a slash mark because square root of 3 is not an integer. It's not an element of the set. Isn't that exciting? Welcome to the world of math. How about letter D? Use the subset symbol to show the relationship between A and B. So look at letter D. Letter D says A is all triangles, right? And B is what? All polygons. They are asking you this question. Use the subset symbol. What's the subset symbol? This little guy. So here is your choice, ladies and gentlemen. This is what they're asking you to show. Is A a subset of B, or is B a subset of A? And what you are asking is this: are all triangles polygons, or are all polygons triangles? Only one of those is true. Are all triangles polygons, or are all polygons triangles? I'm hoping somebody out there could work through the muck of all that. Emma?
All triangles are polygons.
Right. All triangles would be polygons. Triangles are a subset of the polygons. This would not be true. You could cross that off there. Okay, did you get that? Because you can draw a polygon that's not a triangle, right? Here is a polygon, not a triangle. So far, so good. Raise your hand if you're having fun. Wow. That kind of hurts a little. Look at letter E. A is all real numbers. B is all rational numbers. Oh boy, ready? A is all real numbers. B is all rational numbers. I just used a little finger. Which one is a subset of which one? How would you write that with subset? Are all real numbers rational numbers, or are all rational numbers real numbers? So how would that look? Somebody answer me, Emily Anderson. No or yes? What? Are all real numbers rational numbers, or are all rational numbers real numbers? Are you looking at that handy dandy gray little sheet there? Which one fits inside the other one? Are all real numbers rational, or are all rational reals? Is that what we're asking, right? Which one fits inside the other? Chase says, no, it's not a yes or no, it's either or. Are all rational real, or are all real rationals? Which one is in the small box inside the big box? Rational numbers are inside the real number box. So how would you write that? Rational numbers, Q is a subset of the real numbers. All rational numbers are real numbers. It doesn't work the other way around. Well, I guess they put letters. I guess set A is a subset of B because all. Right. B is a subset of A because all. Look at letter. Look at letter. Which one are we on? F. Oh, here's a good one. A is all vowels and B is letters of the alphabet. A is vowels. B is the whole alphabet. Which one is a subset of the other? Which one is a small grouping of the big grouping? Joseph?
Vowels are subset to the whole alphabet.
Right. Vowels are a subset of the whole alphabet. Look at Joseph has it. And then, have we discussed Venn diagrams? Have you used Venn diagrams before? Just say yes or no.
Yes.
All right, then look at letter G. See if this helps you. What is G? The numbers of the set G are what? Somebody read them off for me. 3, 6, 9, 12. That's it?
Yeah, and then there's B, 5, 12.
Wait, what? I? B?
B.
B? Wait, was G one?
Yeah,
and B
it's
the other?
A. No,
This
it's
G.
A, B, G is supposed to be A.
Why did I put G there?
Because that's the letter of the
B is 5, 12, 15, 20.
12, 15, 20. Right? So if you are talking a Venn diagram, which means a circle, circles that contain these things. So if this is the letter A, what numbers does A have? 3, 6, 9, and 12. What letters do B have? B has 5, 12, 15, and 20. But at this point, you would look and say, wait a minute, Zach, say that.
Wait a minute.
They both have 12. Zach, that's
Both
right.
of 12.
So what am I supposed to do? 12 is what we call the intersection, right? So that means circle letter B, there is overlap. You need to move Mr. Circle B. 12 we don't need to write twice because it's already in there. See how both circles contain 12, but I still need my 20 inside this line. That's kind of handy, wasn't it? 12 is the intersection of A and B. What would be the union of A and B? Somebody? A union B, what would be the set of that? I bet when you woke up this morning, you probably didn't think that this was going to be as exciting as it is. Anybody, what's going to be in the union there? Brian, what's going to be in the union? If union is everything put together, what would be the union?
3,
3,
9,
9,
6,
6. I don't like to put my
12,
12,
5,
5. Is that all?
15, 20.
15 and 20. That is the union. The intersection of those would be just 12. How many feel relatively uncomfortable that this is or isn't what they should be doing? Anybody? And then look at letter H. Let's just wrap this up with letter H. What would be what does that say? The intersection of all parallelograms and all trapezoids. John, how would all parallelograms and all trapezoids be related? Are all parallelograms trapezoids? Are all trapezoids parallelograms?
All trapezoids are parallel.
John, do you know what a trapezoid is? What would be an example of a trapezoid, ladies and gentlemen? Anybody, what's a parallelogram? Olivia, a parallelogram is? Who? Murray, I think you're over there right now. I think you can sit there between you and for right now. Oh wait, sit right there where there's nobody at that big desk right there. Who was supposed to sit there?
Shannon.
Oh, Shannon. What's a parallelogram? Aaron, you just got here. What's a parallelogram?
That's difference of parallel sides.
And the question I asked John were, are all trapezoids parallelograms or are all parallelograms trapezoids? Which is which? Do all trapezoids have only one set of parallel lines or do all parallelograms have just one set of parallel lines? The correct answer, Madison, is just say you don't know.
I do not know.
What is it when you don't know and it doesn't happen? That
Empty
was
set.
that empty set. It doesn't happen, so it's an empty set. Much like the seventh grade mind.
Thank you.
No, I didn't mean that to be criticism, by the way. I just wish we had more time. What should we do? All right, for tomorrow, listen very carefully. I want you to do problems 16 through 19, lesson 90. 16 through 19.